Hey everybody, this is Scott again. Thought I would take the time to do another quick Phoenix tutorial, kind of build off of the last one I did. Apparently a lot of people found it kind of useful, so I thought I'd kind of dive a little bit deeper into a read-only API, and then eventually get into the other end of the CRUD actions, the create, update, and delete. But today specifically, I want to talk about query params and pattern matching within Elixir. So the example I'm going to work off of is the API that I created in my last video. You can just go to my GitHub page. I'll link to this in the description, and then just pull this down. Really simple. So if we just run this locally, mixphoenix.server, this will be on localhost port 4000, and you can see it's a really simple, just JSON API. It's meant to be, the API backend for a web application. So we have some documents. We list out a bunch of documents. We can go to the projects page. We can see we have a bunch of projects. We can also see documents by ID. So these are kind of the default things that shipped with Phoenix when you use the generators. But now I want to get into actually like filtering these out and querying them. So for instance, I want to get all the documents for a particular project. I only want to get the documents that are published. How can we write queries for that? So we're going to do that pretty simply, and we're going to start by just looking at our document controller, which is here. So again, we are not dealing with the create or update or delete in this video. We're just looking at index, which is typically the action that returns all of ours. So index calls the list documents method on our management context. So if you're unfamiliar with context, I covered this in my last video, but think of context as the real API that controls querying and everything from our backend, whereas this is more where responses come in. They come into these functions, and then ultimately our context handles all that stuff, and that becomes useful because we might want to list all documents elsewhere in our app and other pieces of this context, and not just our documents controller. So let's look at our our management context. And this is just the boilerplate context that's created when you use the generators to create models like document and project. And this is the list of documents function that we have. The document, we do have to preload our relationships. So because documents has a relationship with project, we preload that, otherwise it wouldn't have access to the ID. This is required for the JSON API spec. It puts the project in the relationships hash, and then we just call repo all. Repo all returns all of the documents for us. So let's start with filtering out published versus non-published. So I want an endpoint that returns only the documents that have been published. This applies to a lot of things. Blog posts is the most obvious. I only want to show blog posts that have actually been published by the author. So this is when we get into pattern matching within Elixir. Pattern matching, in my opinion, is just one of the cooler things about the language. It's just a lot of fun to kind of play around with, and you realize it can actually clean up your code quite a bit because you don't have a ton of nested if conditions. So the way pattern matching works is that you can have multiple methods called the same exact thing. But Elixir will pattern match based on the parameters that you list there. So we're going to have another index method. It's always going to take the connection. That's always going to be the first parameter in all of these methods. Oh, and the second thing it takes is params. So the params would be the query parameters that are going to come through in the URL string. You'll see here we have underscore params. This is just telling Elixir that this method is going to accept two parameters, has an arity of 2, but we're not using this one. We don't care actually what the parameters are. So this is essentially a catch-all. And the way methods work in Elixir is that if I had this def index con do and then some stuff, this is a completely different method than this. This is called index/1 because it's the method index and it takes one parameter, and this is index/2. So if you ever run into errors within your terminal, you see this method /1 failed. That means it's telling you it's this method name with an arity of 1. So they are technically considered two unique methods. So that means that unlike other languages, you do have to list out all of the params that you expect. If you're not going to use any of them, the convention is just have them as an underscore. Your linting tools will then ignore them. So how do we pattern match then? If we did it just like this method would actually never get called because we're not pattern matching. We just have names of variables and we're always going to get a match to that even if this is nil. So the way that you pattern match is you can actually just write the value. So the way the query params are going to come through in Elixir is through a map. Let's actually just log what our params are going to be. io.inspect params is going to put that in our terminal, and then just so that things keep working as normal, we'll just have it do what it was doing before. And this is what we ultimately want, status published. So you can see here, this is how it's going to come through. Status published is going to come through in a map, the first key being the query param, status, and the value, which is the value that we typed into the URL. So let's actually just copy this and bring that over here, and we can just paste it right here. So this will specifically match a map with a key of status with the value of published. Now if we change this to status, for instance, now it's a variable that is assigned the value based on the value of this key. So if we did io inspect status, we'll see we get published here. But now if I change this to something else, like foo, you'll see it doesn't get logged here. And that's where the pattern matching comes in. A key came through, or excuse me, a parameter came through, but it did not have a key of status. So therefore this pattern match failed, and then it went to this one. So it always goes from the top to the bottom. It will always try to match the first ones first. And this is our failsafe, right? Because we say, well, we don't care what it is. It can be even, it can be nil, it can be empty, it can have 100 keys to it. This is our catch-all. So usually you want to write your methods with some sort of catch-all, even if all that method does is log an error for you. Cool. So now we have this where we're logging our status. But let's delete this because that's not the method that we want to use. We don't want to just list all the documents. We actually want to list specific documents. In this case, we want to list documents by status. So let's go back to our management context and write a new method because we want all of our querying to happen on that management context because, again, that's kind of the API that communicates with our database. So we are going to call or create a new method called list documents by status. No reason to be clever here. Let's just give it a really blunt name. It will take the status parameter. So what do we do here? We want to do something similar where we called the repo.all method to get all of our documents, but we actually want to also add a where clause. So now we're going to do document. We're going to use the pipe operators because, again, this is just a way for us to chain our methods. The pipe operator calls this function, but it passes the line above as the first parameter. So this is the same as this. The result of this is then passed to this method. Just kind of a cleaner way to write that. So we're going to have to do the same thing here. We're going to have to preload our projects, because again, that's our relationship. We need to preload that in order to serialize it correctly. And this is something that's only really applicable in the JSON API spec. If you're just doing a normal RESTful API that just has the IDs, then you don't necessarily need to do this. It's only if you want to list out the actual relationship itself. Then we're going to write what's called a where clause. So if you're familiar with SQL, you know you can select all from documents where X equals Y. It's very similar here. We're going to say where published is equal to our status. Now when we're in the scope of this method, we need to add the caret character here, which tells it to take the value of this status and apply it here. Otherwise, you're going to get an error saying that that's not defined. And then we're going to add repo.all. So we're going to only find the documents that are published with the status that we've set, and call repo.all. So our status is actually, or excuse me, our published field is just a Boolean. It doesn't actually take a string or anything like that. So we're going to want to clean that up and pass in true or false to this method. So here we could do that a few different ways. We could say status equals, we can kind of write what is essentially ternary. Sorry, let's not call this status. We'll call it status bool, sure. Where status equals published do true, else false. Then we're going to pass that to our management context list documents by status method, status bool. So if it's set to published, we're going to filter it by the true. Anything else is just false. So let's see how that worked. Change this to status, and you can see our result here is only 2 with a published true, published true. If I change this to anything else, unpublished for instance, published is false, published is false. Pretty simple, right? The nice thing with pattern matching is that it allows us to not have to write a bunch of if conditions. So your first thought might be, hey, this could actually be pattern matched itself. And yeah, we could absolutely do it that way. So let's actually do that. So I'm just going to copy this whole method. So now we're going to say, all right, where the status is published, let's delete this line. We're going to say documents equals this true, right? Unpattern matching here. We're only going to hit this method if the status happens to be published. Otherwise, so in this case, I actually don't care what the status is. So just like here, I'm going to say, yeah, this has a value, but I don't really care what it is, but it has to have this key of status. And I'll say false. So let's see if that does the same thing. If I refresh, I get the same exact result, only ones with the published state of false. If I change this back to published, only the ones that are published, so published is true. So there, more pattern matching for us. So we kind of broke this down a little bit further. So now let's go back to listing out all of our projects, or excuse me, all of our documents, and now let's filter it by project. So we have the project relationship. There's 3 projects here. A common case would be I want all the documents that only belong to a certain project. So we're going to do the same thing that we did up here. We're going to filter it by project. So in this case, where project key is going to have a value of project ID, and we're going to we're always going to do this. We're going to create a variable called documents, and we're going to render it here. But now we want to create a new method. We want to list our documents by project. So let's come here and create that method. We're going to define the method of list documents by project, and that's going to accept a project ID. So again, we're going to start with the document. We're going to preload our relationships. And then ultimately we're going to end with repo.all, just like we did before. The difference is we want to add something similar to this, and same exact case here, because we're doing a straight, this key has this value. So where project ID has the value of this project ID, and it knows this caret refers to the variable that is defined above. So if we come back here, we're going to do the same exact thing. Documents equals management dot list documents by project, and we'll pass in the project ID. So now if we come back here, for project equals 1, you can see we're now filtering it to only the ones that have the project of 1. If we do it by 2, we only get the 1 document back, and then 3, we get the 2 documents that belong to project 3. So again, really, really simple. So again, let's go back to our normal index where we're returning all of them. Another variable that we have here is view count. So this is going to be a little bit different, where we're not just filtering it by one specific, give me this one value. Let's say I want all the ones that have a view count that's greater than or equal to 1, for instance. We want to see all documents that have been viewed. So how are we going to do that? Well, we're going to once again create another index method here, index con. And in this case, we'll just call it views, and you can call it whatever you want. That just controls the what query param we type into our browser. And so we're going to do documents is going to equal management dot list documents by view count. I think that makes sense. I like long names. And then again, we're just going to duplicate this line. So now let's create a method by this name. So list documents by view count, and it accepts the parameter of view count. So we're going to use our document, and again we're going to steal this line here because we're going to preload our relationship. Now when we're dealing with where clauses that aren't just a straight this key is this value, we're going to use the where/3 method. So here we're using where/2, where it takes 2 parameters. Here we're going to say where. The first thing it expects is an array that lists the tables that we're referring to. We're going to assign names to our tables, or in this case the tables relate to our models. So we could call this document, refers to this. The convention is to just do one letter that starts with the name of our model, so D. If you're used to writing SQL queries, you do this all the time, where document as D, or select from document as D, and then you do like D dot, etc. So that's exactly what we do here. D dot view count is greater than or equal to our value of this here. So again, caret view count, and then repo.all. So if we come here and we say views is 1, we get all the ones that have the view count greater than 1. If I change it to 2, I actually don't think I have any, then it filters that out appropriately. So that's how we would do a where clause that has some sort of conditional, naming our tables, defining our tables. That way we can declare them here, table name dot property name is greater than that. Cool. So if we come back to our controller, the problem is we have a ton of, in my opinion, gibberish here, right? That's a lot of index methods. That can be really confusing if you're, a new developer to the project and you see all this. It might not be super obvious what's going on. How can we, clean that up? And an easy way to do that is to do it within the management context through, again, pattern matching. So we have all these methods defined. I think these methods will be fine in that they do exactly what we need. But what we can do is we can just make list documents the public kind of API for getting documents from our backend. So let's do def list documents. So we're calling it the same thing as this method, but now we can define a few of these through pattern matching and then call the appropriate function down below. So here we were pattern matching based on a status of published. So let's steal this. We're going to steal this parameter. So when list document gets a parameter that is a map that has a key of status, and that key has a value of published, we're going to call the list document by status method and pass the function true to it. So if you're writing one-line methods rather than doing do end, you could just do comma, do, colon, same exact thing, just kind of the shorthand, and that's going to clean up our code a lot here because that's all we're really going to do. This function and the pattern matches that we're going to use here are going to control which methods below get called. So here we do the same exact thing, except status, we don't actually care what it is. That's what the underscore indicates, and this is false. So let's duplicate that one more time and look at what our next method was. So we're project ID. So again, the list documents function will get called. We're going to pass our parameters to it, and this line here specifically is looking for the parameter where it has a key of project, and we're going to assign the value of that key to a variable called project ID, and that's where we call the method list documents by project, and we pass the project ID to it. And then one last time we take that last method that we created for view count, paste that right in here. Again, this is going to call this method, and it's going to specifically look for parameters of views with a value that we assign to the variable view count, and we call list documents by view count, and we pass that to it. So now we can come here and we can delete all of these. So now it's always going to hit this method, but again, this was kind of our catch-all. The underscore indicates that we weren't using this variable, and then it just calls this list documents method. But now we are actually going to use that variable. So I'm going to delete the underscore, and I'm always going to pass it to my list documents method. And I realize I called this list documents. So it should always call this method now. So if I come here and refresh, I get the same results. If I come here to change that to 1, I get the same results. If I do status published, I get only the 2 that were published. If I do status unpublished, I get the 3 that were not published. And if I do it by project, I get the documents that are only related to project 1. And similarly, just to double check, project 2, we only get that. But then if I go back here, it blows up. No function clause matching list documents parameter with the arity of 1 That's because all of these are pattern matching, and none of them matched our parameters, which were a parameter of nil in this case. So we wanted it to fall back to this method, but this method actually takes an arity of 0. This is list documents /0. That's how it's defined in Elixir. But we're just going to change it, and even though we're not using the parameter that's passed to it, we still want the method to be called. So if all of these pattern matches fail, then we can safely assume that we want to just return all of them. So we'll do that, and when I refresh, I get all of my documents again. So we added quite a bit of filtering to our documents model, our documents controller. We didn't really have to add that much code. Since these methods are only being called by these methods above, I would say that these are private. So you want to change these to def p. So if you're familiar with Rails, this would be our private methods. Normally you would, I think in Rails you define private here, and then everything below it is private. But in Elixir you say def p, meaning no other module is going to call these methods, can only be called kind of within this namespace. Because yes, these aren't public, these aren't part of our public API. And we did that by really only updating 2 lines within our document controller. So now we're just taking the params and always passing it to this method, even if the params are nil, or if they're filtering for something that we just don't have. It's fine, we know it's still going to work. It's doing what it was before, plus it's doing all of this. Really not that hard to kind of add these filters on the fly. Phoenix has a lot of quality of life things like these where clauses and the repo.all that we can add. Cool. So to go over another maybe quick example, let's add a new model. I'm going to add a new model called user to our repository here, and we're going to filter, we want to show results like we do here. If I do documents /1, remember this is like our show method where it finds it by the ID of 1. What I want to do is find users by screen name or ID. So we're going to create a new model, mix phx.gen.json. If you watched my last video, you know I kind of covered how we can create models. So the JSON generator is going to create the migration, the controller, and the model, as well as the view for us. So mix Phoenix gen JSON. The first parameter it expects is the name of the context, and is that manager or management? Management. Then it expects the name of our model, in this case user. Then it expects the plural name of our model, users. And we can optionally pass in the fields that we want. So in this case, I'm just going to have screen name with it, which is a simple string. And we just go ahead and create that. It wants to update our context files, and that's fine. It's just going to add a bunch of stuff for us. So this created a migration. Mix ecto.migrate is how we're going to run that, but if we want to go and look at that here, it's just going to create a table called users and add the screen name as well as the timestamps fields. So let's just run that, mix ecto.migrate. And yes, we're running into that same problem that we ran into in my last video, and that's because that method is trying to call a function that is not defined at the time. We're just going to delete it because we're not going to be creating new users dynamically. Again, we're just going to deal with a kind of read-only API. So I want to insert a bunch of users. Again, if you watched my last video, you know I have some seed files that I added. I'm just going to duplicate this one and create one for the users. User seeds. So this will be user. And I have a bunch created here. I'm just going to copy and paste them in. Really not that important. Just calling repo.insert, and we're going to insert a bunch of screen names here. So to run that, we're going to do mix run priv/repo/seeds/user seeds. and it inserted it into there. So if we do mix phx.server, we should be able to go to our users endpoint and get all of our users. But we're not getting them back because we actually haven't added them to our router yet. So we do have to add that to our router. So when we are going to create a new resource called users, so this is the actual URL that we're going to. So /API/users corresponds to /API/users. This is going to be the user controller, and we're only giving public access to the index and show methods. So again, read only. Let's save that and refresh this. There we go. Here are all of our users. If I go to user/1, there we go. We only get that specific one. User/2, we get that specific one. But what I want to do is I want to be able to do this. User/ then the screen name. Because if you're creating a web interface, you're most likely not going to have your URL just list the ID. That ID is meaningless. If you want to go to someone's profile page, you want to go to like /profile/username, right? Not /52186. That doesn't make any sense from a user perspective. So what we're going to do is we're going to allow that to either query by ID or query by screen name. So let's start by looking at what kind of the public interface is for that. So that's this controller here. So we're dealing specifically with the show endpoint. The show endpoint returns just one record and expects an ID. Takes that ID and passes it to this method called getUser, which lives in our management context. So let's go and find that method. The generator added that for us, as well as some like boilerplate comments which we can delete. But this is all it does. It calls getUser, and it uses the repo.get method. So get expects two parameters. First, the name of the model, and then the ID that we're using to find it. But in our case, again, we want to be able to find it by screen name, not just by ID. So what we want to do is we want to create a new method called user get user by ID or screen name. Let's actually get rid of the get. That's pretty wordy. User by ID or screen name. It's going to take an identifier. I don't want to say ID because it's not necessarily an ID, right? And we're going to make this method call that. So let's, for the time being, just copy and paste this here. And this will call user ID or screen name and pass that ID to it. So just to make sure we didn't break anything, because this should be doing exactly what it did before. We've just shifted the logic down here. If I go to /users/2, unidentified function. Oh, that's because that should be this. And actually, let's call that the same thing here, just so we're consistently calling, because again, it's not necessarily an ID. It could be a screen name there. So how can we pattern match based on the type, right? Because we can't just do it based on the value, because the value could be anything, because we could have thousands of users. So what we want to do is actually do it whether it's an integer or not. And that gets a little bit tricky. That's when we can implement the when conditions within our method declarations. So we can actually say when is integer identifier, because that's just the name of our method here. So let's save that and refresh here, and it blows up. And the reason it blows up is because even though this too is an integer, the query param comes through as a string. It's always going to come through as a string. So this is when we can implement another method by the same name that checks, that tries to parse it as an integer, and if it does, it can call itself. And the pattern matching, again, this is still technically considered pattern matching, will take care of that for us. So let's do def user by ID or screen name identifier when, so in this case a string would be binary. There is no is string method for us. So if is binary do, we want to try to parse this as an integer. So if you're not sure exactly what that's going to output for us, let's just do an IO inspect of it. Integer.parse is the method that we want. Identify. Let's come here. Let's refresh. And this is what it gives back to us. So it gives us a tuple. So if you're unfamiliar with tuples, don't be fooled by the name. It's not called that just because it has two values. Tuples can actually have lots of values. Tuples are like linked lists, except they live in concurrent memory. So they're much more performant than arrays or long lists. But in this case, the integer parse is going to return a tuple that returns the integer and then would return any error information for us. So because it did work out in this case, it was able to parse a return 2. If I put in a bunch of gibberish, it returns, oh, it doesn't return, just returns error. Interesting. Either way though, this is what we're going to deal with. So let's do this. What we're going to do is a case. So case, just like a case switch in any other language, case do. So this is what it's going to return. It's not always going to be 2. In this case, it's going to be an integer. And so we're saying when we get this result, again, this is pattern matching as well, right? So it's going to run this function, and we're going to pattern match the result if it matches this. In this case, if it's an integer, or excuse me, if we get something returned in the beginning part of this tuple, we're going to assign it the variable name int, and then we're going to call user by, we're going to call this exact method, and we're just going to pass that integer to it. Otherwise, we get an error, and we're not doing anything with the error body. That's why I'm just going to underscore it again, because yeah, I'm not doing anything with it. So if we do get that, then we can assume, you know, it is a string, and then we can query the user that way. So we're going to get the user. We're going to write a where clause just like we did above, where screen name is identifier, the caret indicating that that value comes from above out of the scope of this method. Then we call, or we can't call repo.get because repo.get expects 2 parameters, the user and the ID. It specifically maps to the unique identifier on the table of ID. But repo has another method for us, which is just called repo.get. Or excuse me, not repo.get, repo.one. We use the bang because that just indicates that it'll throw an error if there is an issue with that. So repo.one will return just one result for us. So I believe even if the query had multiple results, repo.one would still only return one result for us. So just to kind of go over this, get user takes the identifier. That could be an ID or a screen name, and just essentially forwards this on to this method. And I want to make these private again, because this is where all of our logic lives, and these should be private methods. So this one first looks at it and says, all right, is it an integer? So when this is an integer, do this. But as we know, the first result almost is never an integer. It's always going to come through as a string in the query params. So it's going to fall to this method. When it is binary, which a string is, we're going to try to parse it as an integer. If that works, if we do in fact get an integer back, we'll then call that method again. So we'll start this over. It's going to come up here and say, oh, it is an integer. Great, repo.get, pass that ID. Otherwise, we are going to query by screen name because that's what we assume the user is trying to do. So that might not be the case for you. If you're using UUIDs, obviously you might not have integers as your unique identifier, but again, this is how you would kind of want to approach it. There might be a lot of different cases where you're querying by an integer or some string. Just to kind of show you that I can define a method and then have a when clause to control when that method is called. So let's come back here. So if I go to user/1, great, that works. If I go to user/Volgin, hey, that works too. If I go to user/thrall, then I get just that one back. And then if I go back to /users, I get all of them back. So, seems to be working for us. Pretty straightforward. Again, we didn't really change that much. You know, we added these functions, just a few lines, 14 lines of code. It's not too bad to do something that's, you know, normally would require a bunch of weird if conditions, but the pattern matching allows us to isolate our logic and kind of deal with it in specific cases, which is nice because if this, you know, this stuff ever changes, I only have to change this method, and this one can, you know, be left alone, and I'm not going to introduce a bunch of breaking changes. So that's kind of it in a nutshell. Pattern matching and query params, pretty straightforward. Obviously, they can become much more detailed. You can have a bunch of different where clauses, different types of query params coming through and filters and stuff, but hopefully you can kind of take what you saw here and extrapolate that and apply it to lots of other things. I'm going to go ahead and cut a new branch and push this up. I'll list the branch in the description, so feel free to pull it down and play around with it. If you have any questions, just leave a comment. Thanks so much for watching. Bye.